we're going to take a look at the last possible way of going through and doing these things. Plug it in. So, it's called the elimination method. So, depending upon how you do things, or how the equation is set up, things tend to work better in using one of the two methods. Now, one of the things that we've seen is that we've got graphing. What? So if I look at this, graphing is a really quick and easy way to determine whether or not we actually have a solution. I mean, if I graph it out, I can see that they're either going to be parallel, or that they intersect, or that they turn out to be the exact same line. Now, it's when we have a consistent and independent system that we've got a bit of a problem. If I take a look at where this is intersecting, do I know exactly where it is? And the answer is no. I mean, I could blow this up as big as I wanted to, and I still would not be able to determine. It doesn't look like it's going on a specific intersection of the lines on the grid. That's where we need to either use substitution, or what we're going to take a look at today is elimination. Now, for elimination to work, things have to be lined up to begin with. So, what I recommend doing is always putting the equations in the order of ax plus by is equal to c. If you always have it in that order, then you've got a good starting point. So if I take a look at the first equation that I have here, all I really got to do is flip that around. So I got 3x minus 2y is equal to 15. Now, for the next one, that one I'm going to end up having to change a little. If I look at it, I see that I need to go and add 2y to both sides. If I add 2y to both sides, what I end up with then is going to be an x plus a 2y is equal to negative 15, or negative 11, sorry. Does that make sense to you guys? So all we've done is just move things around. Now you'll notice that the x's are lined up, the y's are lined up, and the numbers are lined up. Now, next step. When we're doing elimination, what we want to do is have the same variable same coefficient opposite signs. Okay. So these three things are extremely important. They're the whole key to it. If I have the same variable, with the same coefficient, and with opposite signs, I've got them. So my next question for you guys is, do you see a variable that has the same coefficient and opposite signs? Now when I look at this, I got an x here and I got a 3x here. Same variable, those aren't the same. If I look here at the y's have 2's that are the same. So I got the same variable with the same coefficient with opposite signs. Okay. So that's what I want to drive at. Then what we are able to do is combine these together. So we have 1x 3x gives me 4x. A positive 2y and a negative 2y, do they wipe each other out? Okay, so they're gone. And this is going to be equal to 4. Now, do you know how to solve something like this? That's 4x is equal to 4. Divide both sides by 4, divide both sides by 4, x is equal to 1. Now, just like when we had done the substitutions, we substituted one variable in for another, went through the whole process, solved it for a variable. Now all I have to do is put this back into one of these. Which one? Absolutely does not matter. So what I'm going to do is I'm going to take my x is equal to 1, and I'm going to put it back in up here to the second equation. Which equation, like I said, doesn't matter. So that would end up giving me what x is equal to negative 11 minus 2y. So what was my x? My x was 1. So now I just simply have to solve that. So 1 is equal to negative 11 minus 2y. Add 11. So I get 12 is equal to negative 2y. Divide by negative 2, divide by negative 2, and I get negative 6 is equal to y. So the final answer for this one turns out to be 1, comma, negative 6. And again, whenever we are dealing with x's and y's, whenever we are going through and dealing with lines, we want to make sure that we go and set this as a set of coordinates. Questions on this one? Anybody want me to back up and put it on a specific spot so you can finish copying something down? These aren't all that bad to deal with. In fact, if I've got my options available to me, I'll go with elimination first. Okay? So, what do you hear? Did you guys finish writing things down? All right, let's take a look at the next one. Now, they want us to go through and solve this and classify the system. Now, if I look at this, do I have the same variable with the same coefficient with opposite signs? When I am looking at this one, do I see that? And the answer is no, I don't. So, in this instance, what I want to do is pick one. Okay? How do I pick one? Well, what we want, same variable, same coefficient, opposite signs. Do you see one of those conditions met? Do you see a condition where we have the same coefficients? Do we see a situation where we have opposite signs? And yes, on the x's. I have a 2x on top, I have a negative 3x on the bottom. So that's what I am going to target. Now, technically, there are at least two different ways to start this legally. Okay. There isn't really one specific way to do it, it's just the process. So, what I would do is I would take the top equation, multiply it through by a 3. Take the bottom equation, multiply it through by a 2. What does this do? Well, if I go and take 2 times 3, I get 6. If I take 3 times 2, I get 6. So that gives me the same coefficient. So the result here is going to be 6x plus 15y is going to be equal to 81? No, 91. 91 plus 12. 34 times 3, sorry guys. That'd be 102. Yeah, 102. Which would be negative. Remember, when we multiply an equation through by a value, everything gets the same thing. Now, if I do this to the bottom, what is 2 times negative 3? That'll be negative 6. Then it's going to be plus 4y is equal to negative 88. So my question is, did I get a variable with the same coefficient with opposite signs? And the answer is yes. So now I can go through, combine these things together. That disappears. This gives me 19y. This gives me c, negative 190. Divide both sides by 19. Divide both sides by 19. Y is equal to, what do I get? Negative 10. Now, I can put this negative 10 into any one of those two original equations. It will not matter. So I look at this, which would be easier to work with? Well, I'd rather divide by 2 at the end than 3, so I'm going to go at the top. So I'm going to take 2x plus 5 times whatever that is. It's equal to negative 34. I put in the negative 10. Now I go through and solve. 2x minus 50 is equal to negative 34. Add 50 to both sides, and I end up with 2x is equal to 16, correct? Divide both sides by 2, divide both sides by 2, x is equal to 8. So what this means is that the solution for this thing is going to be the coordinates 8, negative 10. So, I'm supposed to classify this. What do I got to classify it as? Well, did I get a solution? Yes. So it is going to be what? We need to back up, take a look at that again. It's a consistent system. These lines are going to cross, so it's going to be independent and consistent. So we would just identify this as independent and consistent. That's it. Nothing here is really difficult in the algebra that we're doing. It is simply the process that we have to go through that is a little challenging. It's knowing what the steps are. Okay. So, ready for the next one? Let's take a look at another example. Now, this one looks flat out ugly, doesn't it? It's got fractions. Well, what do we do to get rid of fractions? Could I take this entire equation up here and multiply it through by a 4? Would that get rid of my denominator for me? Yep. So if I take that, it gets rid of my denominator of this, so I'm left with 3x is equal to 12y. Okay? So I did that to begin with, got rid of all of my fractions. So now, is it in the way I want it? No, it's not. This equation has to get moved around. So that means that I would end up having, I could have negative 3x plus 7y is equal to negative 15. Does that make sense? I wanted the 3x on this side, so I just subtracted it. That's why it's negative. I wanted the 15 on the other side, so I made it negative, subtracted it. Now, do I have to do anything with this one? Yeah. So this one turns out to be 3x minus 12y is equal to. What's left on the other side? If I have nothing, what value do I put in over there? 0. Addition and subtraction, whenever we add or subtract and things disappear, it goes to 0. When we multiply and divide and things disappear, it tends to go to 1. So that's the difference. Now, the question comes up. Do I have the same variable with the same coefficient and opposite signs? And the answer is yes. I've got this right here. So, this eliminated by that, I am left with 5y negative is equal to negative 15. Correct? Would you agree? Divide by negative 5, divide by negative 5, y is equal to 3. Always helps if I put down y. Okay, so y is equal to 3. Now remember when I said that I could put this in any place that I wanted to solve, correct? I could put it up here, I could put it here, I can even put it here. And since I don't have to mess with that fraction, I'm just simply going to put it in up over here. So I'll have 3x is equal to 12 multiplied by the y. Well, what's y? 3. So now I end up with 3x is equal to 36. Divide by 3, divide by 3, and I get y is equal to 12. So that means this is going to be 12, 3. Again, we have a consistent, independent system. So far, so good? Okay. So try another one. Ooh, more fractions. Ugly, 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 right? So, well, let's see. I look at this. I want to get rid of a 6 and an 8. What's a good number to multiply through to get rid of a 6 and an 8? Yeah. Well, what kind of a number would they both share? Okay, if I did 2, but would 2 cancel with 6? No. I'd still have a 3 on the bottom one time. I got to get a bigger number that wipes out more than just the 2. And not only that, then I'd have a 4 left on the other side. Have I got another choice that I could use? Think bigger. 24, absolutely correct. So, if I go and I'm going to rewrite this out a little bit more so you can see the work. So if I've got 24 multiplied by 5, 6x plus 24 multiplied by 7 eighths y is equal to 24 multiplied by 25. So, I realize this goes back to multiplication with fractions. Now, does 6 cancel with 24? Yep. How many 6s are in 24? 4. 4 times 5 is 20, so I have 20x. 8 cancels with 24, and I get 3. 3 times 7 is 21y. And 24 times 25, oh, let's see, that turns out to be 800. Huh? 600? Oh, yeah, because there's 4 quarters in 100. Yeah, 600. Went the wrong way. Okay, 600. Okay, so I got that one ready to roll. What about the one down here? What should I multiply this equation through by in order to fix it? Well, what are my denominators? Well, my denominator is just that 3, isn't it? So, I'm just going to multiply everything through by 3. This one's a little bit easier to see, so I'm not going to worry about it too much. So I'm going to write this one as x, because that cancels with that, plus 6y is equal to 3 times 76. That would be 228. 228. Yeah, every once in a while I actually get close. So, now, my question is for you. So, I need to get a variable with the same coefficient with opposite signs. What would be a good one to attack? Would the y's be a good thing to go after? Well, I got a 6 and a 21. That kind of looks ugly, right? Would the x's be a better one to go after? And the answer here is yes. Because I do not have anything on this x, I could multiply it through by something so that I'd get the same variable, same coefficient with opposite sign. So my question is, what should I multiply the x by? Negative 20. So if I multiply through by negative 20, negative 20 times x gives me negative 20x. Negative 20 times 6 gives me negative 120y. Negative 20 times this over here, that gives me what, 4560? 4560, right? So I double 8, that goes to 16, double the 2, goes to 4, plus 1 more is a 5, double the other 2. So now, this cancels with this. So when I take care of this, that means I end up with negative 99y, yes? Is equal to, and this is where a calculator comes in awfully darn handy, because I mean, you got all this arithmetic. Don't try and do it in your head. Use a calculator, please, because I want you to understand that concept. What is it? Oh, boy, you're asking me to do that. That would be 3960. Tell me if I'm right. Negative 3960. Yep. Okay. Now, what's the last thing I got to do? Divide by negative 99. Divide by negative 99. And y turns out to be equal to what? 40. Okay. So, I've got 40 there. Now, where do I want to put this in? I want to put it in where I got the least amount of fractions. So, could I take this, pop it in right there? Sure I could. So that's going to be x plus 6 times whatever y is equal to 228. So that's going to be 40, so that means x plus 240 is equal to 228. Subtract 240, subtract 240, and I end up with x is equal to negative 12. So, as I've gone through and done this one, that my answer turns out to be negative 12. Not bad. Fairly easy to deal with. It is a lot of mental gymnastics again. But the biggest problem with this is when you are doing this, same variable, same coefficient, opposite signs. That's the catch. So, ready for another one? Now, there is always going to be the possibility that we don't get an intersection out of this. So, again, we're aiming for the same coefficient, same variable, opposite signs. Do I see something that would work that way? Well, when I look at this one, I got a 2x and a negative 6. I got a negative y and a 3. Now, mathematicians are a lazy lot. We want the simplest, most efficient way to deal with things. So I'm looking at this. I got the 2 and the 6. I got that negative y. Whenever I have something that does not have a coefficient on it, I am going to target that. So what I want to do here is I'm going to multiply this top equation here through by whatever it takes to get my opposites on the y. And that looks just like a 3, right? So when I take 3 times this, I get 6x. I go over here, I get negative 3y. I multiply here, I get it equal to 9. So, do I have my same variable with the same coefficient with opposite signs? So, that disappears. That disappears. So I got a 0 on this side. This is over here with a 0. Right. Is this right? Did I do everything right? I mean, I got 0 is equal to 0. Okay. When I have this, 0 is equal to a 0, so this turns out to be exactly true. So that means that this one here for the system is going to be consistent and dependent. Why? Because it depends upon where you are to determine what's equal to what. But when you get this where a value is equal to itself, consistent dependent. Just like we had seen when we were doing substitution, we would get these situations where it would be equal. Okay? Let's take a look at a situation when we get something different. Now, I'm looking at this one. I got a 3x and a 6x, a negative 4y and a negative 8y. Okay? I want to get rid of something. Well, I think what I'm going to do here is I'm going to take the top equation, multiply it through by a negative 2. Because if I take negative 2 times 3, that gives me negative 6x. Right? So I got the same variable, same coefficient, opposite signs. When I multiply that over here, I get plus 8y. When I multiply that over here, I end up with 48. So, 6x, negative 6x disappears. Negative 8y disappears. Hey, I get a 0 on this side. But, over here, I end up getting, what is it, 62? Oh, 64, sorry. Is that possible? And the answer is no. So because this is not possible, there is no solution to this. So this is just simply going to be inconsistent. All it is. You get something like this. That's the way it ends up. So, what I want you to do is I'm going to give you a few minutes here and I want you to go through and work on this. So now that I've done all of that, moved everything around, I'm going to put it into, which one? Everybody got a choice? Nobody has a favorite, huh? So how about I go and put this into this equation right there? So that leaves me with negative. What's x? 8 is equal to negative 22 minus 2y. So let's see, I add 22 to both sides, add 22, And let's see, 22 and 8 gives me a grand total of 14 minus 2y, divide by negative 2, divide by negative 2, negative 7 is equal to y. So that means that our coordinates would end up having to be 8, comma, negative 7. Now, questions. Did anybody actually get 8 and negative 7? Thank you, Dave. Questions about why I did what? Huh? Yeah, start with one. Ask me why I did what I did. Okay, when we're moving things around up here, I want to have things in this form. Ax plus by is equal to c. Okay, that's what I want to see. That's the order I need it in. So, the c is like the 62. That's just a plain old number. The x, is it on the wrong side of the equal sign? Is the x on the wrong side of the equal sign from what I want? Do I want the x on the left side or the right side? Left side. When I'm looking at this equation here, is this x on the left side? And the answer is no. How do I get it over there? Yeah. Well, we'll give another try here once and see if that one little thing helps shape things. Give you a few minutes. Here we go. Again, my question comes in, is it in the proper form? Well, I look at the first one. Do I have the x and the y on the left side and the number on the right side? Yep. So we're good to go there. So that means that I've got my negative x minus y equal to negative 3. Do I have the same situation on the other side? That would be a no. This 2y shouldn't be here. It's got to be brought over to this side, correct? And let's always add the opposite. So that means that I am going to get 3x minus 2y is equal to negative 11. Because in order to get it over here, we've got to subtract 2y. Now, the question comes, which one of these variables do I want to get rid of? Well, what's the easy one? Is it easier to get rid of the x or the y? And generally speaking, if you just have to multiply through by a number, not a signed number, tends to be a little bit easier. But we will get rid of the x's, most definitely, because when I can multiply this top equation through by a 3. Okay, why a 3? Because if I take 3 times negative x, I get negative 3x. Is that going to eliminate my x's? Yes. 3 times negative y minus 3y. 3 times negative 3, negative 9. So far, so good? So, I combine these things together. Positive 3x, negative 3x disappears. Negative 5y is equal to negative 20. Divide by negative 5, divide by negative 5, y is equal to 4. Now, where do I want to put that? Well, it might look like I should put it up into the first equation because it's got a plain old y there. But putting it up here is actually going to turn out to be easier. Why? Well, if I've got 3x is equal to 2 multiplied by whatever y is minus 11, it gives me a number over here and I have to divide. Otherwise, I got signs up there. It's all personal preference. It's all what you see. What seems easier to you. Okay? So this ends up being 3x is going to be equal to 8 minus 11. 3x is going to be equal to negative 3. So x is equal to negative 1. Boom. So that means the solution for this one is going to be negative 1 comma 4. And it is going to be a consistent independent system.